All right, well, I don't love the pile of integrals many folks just make their exam using, right? I do think that there is some value in seeing if you know how to choose a technique to use on an integral. So 14 and 15 are our first places for you to show me that you could choose a technique out of our arsenal of techniques to solve this. So evaluating this integral, first thing I notice, it's already nicely factored for me. Doesn't feel like it's got a trig sub vibe. There's no x squared minus 3 and can't use sub. Could maybe do a use sub trick, but probably not because unfortunately we have two terms in the denominator, so we would just move our problem to another place. Integration by parts feels like a no-go. Trying to think if there's any way that could help me. I think it's just going to make things worse. Right, I have to rewrite this as a product, and both products would have would be rational functions. That's just gnarly. So I mean, this seems like a pretty obvious partial fraction decomposition question to me. So 18, I'm going to do my floating math, x squared, x minus 3. This is actually, I'm going to go ahead and do this as repeated linear factors for that x squared. Again, we discussed it doesn't really matter how you do it. And then a c over x minus 3. If I were to go ahead, multiply both sides through by my denominator, I get 18 is equal to ax times x minus 3 plus b times x minus 3 plus c times x squared. And then if I'm doing strategic substitution, I have two options that are really smart. We have x is equal to 0, which gives me 18 is equal to negative 3b. So my b is equal to negative 6. I have x is equal to 3 as another smart thing to use. There we get 18 is equal to 9c, so we get c is equal to 2. And then we'll go ahead and just use 1 as another smart number to use in a strategic sub question. We have 18 is equal to negative 2a minus 2b plus c. And we happen to know the other two pieces, negative 2a plus 12 plus 2 is 18. So I have 14 here that I can go ahead and subtract off from both sides. We have 4 is equal to negative 2a, or a is equal to negative 2. So we're able to rewrite this original integral as negative 2 over x plus negative 6 over x squared plus 2 over x minus 3. And all of those things we can quite easily take antiderivatives of. We have negative 2 ln of x. The back one is going to be plus 2 ln of x plus minus 3. I'll get my plus c in there. The middle term is the only one I'm going to have to think just a little bit. I'm going to have to do a baby rewrite to negative 6 x to the negative 2. So this will become x to the negative 1 plus 6 as my coefficient, because I would have divided that negative 6 by the negative 1. I can move this over then. Let's go ahead. Let's make it cuter. And that's it. We're done. Nice little partial fraction decomposition from start to finish.